Alright, a couple things I forgot to mention. I think I alluded to it, but this will be a logarithmic scale. That's what that is. And over here, this is I. What I is, like I sort of alluded to it, but I didn't say it outright. Because we're playing with units here, this is actually the square root of a unit. The square root of -1 is the square root of a unit. It's not the square root of a number. -1 is not a number. -1 is a unit. We took the square root of it. Okay? Now, when we take, and you can see this very easily, because if we finish this out, right, if I this is going to be the negative square root of -1, right? Okay, so here we have our half power to -1. Here we have our first power to -1. Here we have our 3/2 power of -1. And here we have -1 squared. So we square this unit and we get this unit. We go from negative to positive. But we square 1 and it just sits there. Right. So this isn't the base unit of this dimension. Really. The base unit of this dimension is more accurately -1, which is a very interesting counterintuitive result. Because you expect the base unit to be 1. But there's a reason for this. There's a fundamental reason for this. And it kind of comes about in the way that we write things. When we write 1, it basically means +1. Whether that 1 can have a sign or not, we tend to think of it as the same as -1, or as +1. Why the hell I said that? Right. So, you know, like a natural number, 1, is different than the integer +1. Those are different things from each other. But we don't write them differently. But when you get into the integers, which is what this is built on, you know, integers puts, you know, the fractions and the irrationals insert, so you get the reals. The thing that allows you to do that, the thing that distinguishes that from the natural numbers, is the existence of -1. -1 is the fundamental unit of this full dimension. Without -1, you cannot have this full dimension. Without a sense of negative and positive, you cannot have this. You have to have that polarity. So -1 is the base unit of this dimension. And what we're doing is we're taking the square root of that base unit. And the reason that we start at 1 is because when we're taking powers, we always start at 1. It does not matter what your unit is. Right? So, flip this over, draw this out maybe more correctly. So, you know, you always start at 1. This is where you start, at 1. Okay? And then your first power will be whatever your number is. Whatever your, the thing that you're raising to a power is, because it can be a unit too. Right? And your second power will be this one. And let's maybe make it a little more interesting this time. Let's do cube roots. So we've got it like there and like there, right? So 1, or what the hell am I doing? Cube root of n. What is this? This is the cube root of n squared, and these are the same distance. Assume that I did this correctly, right? And then you get these other ones. So this is the cube root of n to the fourth, the cube root of n to the fifth, and that carries on. All right, so you can do anything like this. You know, any root will just be that fractional distance, right? So cube root is a 1/3 power. So we'll take 1/3 of this distance, but this can be anything. This can be a number, it can be a unit, or it can be a full-on vector, which is the combination of numbers and units. And then over here, if we go the same way, we get 1 on the cube root of n, 1 on the cube root of n squared, and 1 on n. This is the negative first. This is the 1/3, the 2/3, negative 1/3, the negative 2/3. Alright, and that carries on. And this is the 4/3, and the 5/3, and this is the 6/3, which is 2. 6 divided by 3 is 2. This is the 3/3. 3 divided by 3 is 1. Right. So you can see that the things that we've been told mostly are very elegantly displayed right here. But then there's some extra things that you haven't probably been told at least very clearly. Like, how can you have the square of a unit? Well, what is acceleration? What are the units of acceleration? Right. So, yeah, the units of a velocity is going to be what? Distance over time, right? Miles per hour, kilometers per second, something like that, right? So you have distance on time. The integral of that with respect to time is position, which is just distance. But the derivative of this with respect to time, acceleration, is distance per time squared. These are just the units, right? So yeah, if you're actually doing this, then you're going to get a half, and, you know, shit like that. Anyway. So you're going to have seconds squared, right? So it'll go a meter per second per second. If this is time, if this is our unit of time, well, this is what's happening. This is how we can do that. This is how this makes sense. Right. So one of the biggest lies that you've been told is that mathematical operations operate over numbers. They do, but they also operate over everything else. Because a unit is literally... okay, I made that into a T. Literally anything. Like -1. Seconds. Years. Light years. Doesn't matter. And every once in a while you'll see like the square roots of a unit or something like that. It comes about. It happens. So, here, what we're doing is we are now recognizing that the base unit of the real numbers is actually -1, not 1. Because with 1, we kind of get stuck. We just, right, 1 to any power, we don't go anywhere. We're stuck at the starting line. But -1 to any power, hey, that moves around. That allows us to do work. That's the base unit. We can, and it also expresses the fact that this is a dimension, because the square root of it is a different dimension. Just like the square root of 2 is a different value from 2. This moved us on our number line. This moved us within, I don't know, our Hilbert space? Sure, whatever you want to call it. Because we're working with units here. We're working with dimensions here. And here we're working with values, numbers. Even though root 2, in a strict sense, isn't really a number. But it's fine. Yeah. Yeah, it works this way. This thing that you are raising to powers can be literally anything.